Let's say we start. So hi and welcome to the talk on 12-factor cloud-native enterprise Java applications. So a buzzword-driven talk here. So hi, from my side, my name is Sebastian Daschner, born and raised in Munich, Germany, so almost neighbors. And I'm very happy to be back in cold Sweden, or at least every time I come here it's kind of cold, but I maybe should come in other seasons than spring or fall. And yeah, I'm a so-called developer advocate for this company called IBM, and I do a lot of things in the Java space. So I've been a consultant for a bunch of years and doing a lot of things in Java and enterprise software related space. And I want to talk about what 12-factor applications are, what the cloud-native buzzword is, and specifically, with the example of Java Enterprise, how to implement that in enterprise projects. And well, first of all, why we should care. So here's a quick poll. Who of you knows about this term 12 factors? Hands up. Okay, a few of you. And cloud-native? Hands up. Oh, okay. So the 12 factors, to start with that, I'm going to briefly introduce what that is about. That's like a manifesto or a website published by the folks from Heroku. And it literally describes a modern software as a service / backend application. So there are a few concerns, 12 to be precise, that describe, well, how we should build a modern enterprise application. And there are a few things such as, well, you should store your code in a code base, in a repository, under version control, and a few other things. So later on, we will go through all of them, and then we will see why that might make sense to follow these principles. And of course, well, how to do that in a modern enterprise Java world. And another thing is the term cloud native. So cloud native is somewhat extending these 12 factors, these 12 concerns. And despite the name, it's not that much about cloud offerings, such as you have to run your enterprise applications in the cloud. It's more about technology. And specifically, it's taking these concerns of the 12-factor applications that we will go through in a second and add other concerns that we might need for modern applications, concerns that we cannot ignore, such as resiliency. We want to build our applications, in a resilient way, specifically once we start distributing our systems to have multiple so-called microservices, multiple deployments that communicate with each other. Same is true for observability. Of course, you could argue that was always the case in the past. Once you build enterprise applications, that you should somehow enable this observability, that you should be able to know what's going on in production. But specifically in a microservice world, or the more you distribute your workloads, this topic gets more and more important. And then a few other concerns such as service discovery, traffic routing. We could also add security or API management. A few more concerns rather these 12-factor applications. But now I'm actually not a big fan of slides, so I want to do live coding and live demo with you. So I'm going to introduce a small microservice example, the simplest example with 2 applications. And for me, I don't know about you, but I love coffee. So we're going to have an enterprise coffee microservice example. So I will have 2 enterprise applications that are written with enterprise Java that we are later on going to deploy in a cloud-native setting, and where I'm going to describe all these concerns and how they implement it, specifically with a modern enterprise Java and Java EE / Jakarta EE approach. So this example is basically comprises 2 applications. One is called Coffee Shop, and the other one is called Barista. So the way how this works is, you as a customer, you'd like to order some coffee. So you go to that coffee shop to make a coffee order. And then that coffee shop has to talk to that barista person, that friendly person who then makes your coffee. For example, we have a nice stand outside where you can get some good coffee rather than the usual conference coffee. So how that works is as follows. You basically, as a client, say, please order some coffee, make me some coffee, the coffee shop. And then for the sake of the example, we will have a synchronous communication from the coffee shop to the barista system. So synchronously, we say, please start the coffee brewing process to the Barista system before we return to our client, just to be sure that, well, the order will work later on, that there are enough coffee beans in stock, and so on and so forth. So for our example, that will be a synchronous communication. And we will use HTTP. So we do something like, please post to these orders at the coffee shop system in order to create a new coffee order, and so on and so forth. And that coffee shop system internally does a call to the other backend. And then we will, well, take a few things into consideration. For example, how to do this in a resilient way, or how to deploy that and later on, and how can we do the service discovery, like we saw before with the Barista backend. How do we look up that service? And so on and so forth. But now, finally, let's go to see some code. So what I have for you is a Java Enterprise project, or actually two of them. This one is a Maven build, a Maven project that builds the coffee shop project. So these two applications, of course, will be two standalone applications, self-contained systems, basically. That will be deployed in a cloud-native setting later on, and they run on a Java EE 8 approach. So that will run on an application container later on. And just because I'm brave enough, this will run on JDK 11. Who of you uses Java 11 in production? Hands up. Oh, I didn't expect that. Nobody will raise their hand at this point. So yeah, that's very brave. You should update. You have a few more months and years left, right? And we will run this, of course, in a cloud-native setting. So how do we deploy this later on in our setting? So what I use for our cloud-native approach is I use Docker and Kubernetes. So this workload will later on be deployed on a Kubernetes cluster. So that means it runs in a Docker container, which will be deployed to Kubernetes. And then I will show you how this choice of technology will implement these 12-factor concerns and these cloud-native requirements. So who of you has used Docker / or Kubernetes before? Hands up. I think most of you are familiar with that, at least with the Docker approach, right? So in order to build that, what we do is we have our project here, coffee shop, right? And what we typically do, we build this using Maven. So we do something like a Maven clean package, right, in order to get our web application. And then, well, we want to Dockerize that and deploy it to Kubernetes, correct? So what we do is we need a Docker file, of course. We have a coffee shop project. And then what we do in our Docker file, we basically describe everything that we need in order to run this in production later on, everything our software needs, including, of course, the project itself, the application, including some runtime, such as an application server, including the Java version and optional configuration and everything we might need, right? So I prepared a base image for that that uses OpenLibity. That is a Java EE 8 capable application container that runs on, well, JDK 11 and so on and so forth. I add some server configuration, and then I add my application. So that Docker file is quite simple. And then, of course, I can build this. Most of you should know that. I use Docker build, right? And the, what's it called, coffee shop name, we call this 12-factor. Always give your builds unique build versions. And then we build it, and of course, we push it to the cloud, right, to Docker Hub. And the nice story about that container approach, specifically if you do thin deployment artifacts with Enterprise Java, is that even over a slow conference Wi-Fi, you can push this quite fast because you actually only push what has been changed. That is the latest layer in your Docker copy and write file system, which is literally your application. You do not push the megabytes of data off your application server and JDK each and every time. All right, and then we do the same thing for the Barista system. The Barista system is literally a very similar application that in my case uses, well, very similar setup. I use a micro profile here that is basically a bunch of Java standards, Java EE standards, CDI, JAX-RS, JSONP, plus a few other extensions. I will talk about that in a second. But other than that, it's very similar. It's also, well, enterprise Java built on JDK 11, and that's also, you see that in the Docker file, deployed to an Open Liberty application server. So very similar story. That means we can also build it using Maven, and then build it into a Docker container. By the way, I forgot to mention, do you have any questions so far? If you have any questions, then please just feel free to interrupt me anytime and raise your hand and ask some questions. So same story before, we will build this and Docker push this. Now we have a Docker image of our two applications that we could run locally, right? But this is not quite cloud native setting if, well, we would need some more concerns. For example, we would like to have some container orchestration, or we would actually like to run this in the cloud, maybe. So what we would like to add is, well, some Kubernetes cluster. I could run one locally using Minikube or similar things, or I could just go to a cloud offering and get one. I use the IBM cloud, for example. They have a managed Kubernetes setup. So what I have is I already have a Kubernetes cluster configured here that runs in the cloud. And I can use this CTL, kube control command line tool to see what Kubernetes services and pods are running. And as you can see, this cluster is empty. There's nothing running there, right? So let's change this. Let's deploy something to Kubernetes, and then we can have a look at, well, what these 12 factors tell us about how we should build modern applications, and specifically how we can implement these concerns. So who of you has used Kubernetes before? Hands up. Oh, a few. So how this works, what you saw in the Docker file is basically a declarative approach how our runtime should look like, right? What our runtime should include, what our container should include in order to run our application. So you basically specify everything that our application needs in order to live, right? Our application server, JDK, configuration, whatever you use. And that's very technology agnostic. You can run anything in a Docker container, right? So for Kubernetes, we need a somewhat similar thing. We also want to have some infrastructure as code file, some descriptive approach to specify how our, well, overall cloud native cluster, how our environment, our production environment looks like. So we do this in a similar way using the YAML file format. And whether you like that format or not, this is what's typically being used for Kubernetes. And we specify, well, so-called service resources. That defines just a logical abstraction over our application. So we will define a service for the coffee shop project and one for the barista project. And then also we will run this as so-called pods. These are the resources that I just asked for. And pods are typically managed by deployment resources. So what we do, we find a deployment for our coffee shop project, and that basically says, well, please run our Docker image, our coffee shop, what I just built, and run this with one replica. Run one version of that. And then, well, the same is true for the Barista system. Same story, we define a logical service for the Barista application, and then we define, well, an instance that is backed by that. And we will talk about that a little bit more in a second, how we can, for example, scale this. But for now, let's just deploy this on the cloud. So what we do, we have this kube control apply command to basically say whatever is described in this YAML file, take it and run it in the cloud. So we're going to apply the deployment script here. It's going to create a bunch of resources. And the same is true for the coffee shop project. So basically, we take these two resources that I just showed you and deploy them on this Kubernetes cluster. What we then have is, well, hopefully we created these new services, one that's called coffee shop and one that's called barista, that can be accessed from, well, inside or outside of the cluster to basically access our application. And that service basically acts as a load balancer that will balance the load to the actual running containers. So we have kube control get pods. We have running pods there. Now only one, because I only specified one replica each for the Barista system and the coffee shop system. And you see that they are already running. And after a while, they will be ready once the application server has been started up and it's ready to do something meaningful. And then we can actually access our application and finally order some coffee. And then we can talk about, once we have some coffee, we can talk about the 12 factors and cloud native. So now you see that the one is already started up, the Barista system. And once the coffee shop service has been started up as well, we can actually access it. So let's take the IP address of our cluster and say coffee shop. Well, what do we access? We actually have two resources. One is a health checking resource, and the other one is this orders resource /orders that you saw on the slides before. Let me show you the code for that. I use Enterprise Java, as I told you. So what I have is I use JAX-RS to implement these RESTful HTTP services for the health checking resource that basically says OK. So, well, that only has the purpose once we can access that resource, the cluster knows that the application is obviously deployed because we can access it. And the second one is the orders resource that basically takes JSON requests and say, well, we can order some coffee. And in a second, I'll quickly walk through the code for you. But for now, that's this JAX-RS resource where we post some new, well, JSON to this resource orders in order to order some coffee. And then this does something internally, right? So in order to get there, we now access this resource, and it says, OK. So apparently that works, right? That's good. That's good news. So we can also query the orders resource. The orders resource gives us the current coffee orders, and it's also being used to create new orders. So what you see is, well, an empty JSON array. There are no orders there yet. So let's change this. Let's order some coffee, all right? And then hopefully, when I do that, I order some coffee. And as we saw in the diagram, that system should then look up the other system, call and do the start coffee brewing process, query the other system, and then return synchronously. So what I do, if you look at the JAX-RS resource, I'm basically posting some JSON, right? Just HTTP communication. So I use curl here to say I post some JSON there, and what I do, this is a so-called coffee order. So that is a POJO that will be serialized using JSON-B. So that means I have this Java object, this POJO, as JSON. And the only thing I'm interested in is this enum called coffee type. So we can specify the type of coffee that we want to order. So for example, an espresso or latte or, these type of things. So let's do this. Let's say I want to have a coffee type and I want to order espresso. Yeah. Espresso. And then if we're lucky, our system hopefully tells us, yes, that was a success. HTTP 201 created. That resource has been created. And if we look at the diagram, and if we look into the code, then apparently or hopefully this has called the external system, the second system, the Barista one, right? And then we get our coffee. And now we can also ask for it and say, OK, now if we query the orders resource, we can see that there's a coffee and it's currently in the making. All right. So that has worked, obviously. But now to the 12-factor concerns and to see, well, what's going on here. So the 12-factor applications. We have done quite a bit in these few minutes now. We have a Java Enterprise application that can talk HTTP, that runs in a Docker container, and that is now deployed in a Kubernetes cluster. Now, that is just one choice of technology. I can choose a lot of things to run our production workload in, right? I can use on-premise, I can just install an application server by myself, or many more things. But now I want to use these 12 factors in order to show, well, why is that good idea or a good choice to have, not specifically that technology such as Docker or container orchestration, but which concerns, which factors are we interested in as enterprise developers, and why, well, we should do that in a certain way. So let's quickly go through these 12 factors. The first one is saying, well, code base. That means all your code should be tracked under version control. Well, that doesn't sound too exciting, right? We have done that hopefully for years, right? But if you follow the link and read the description, it will tell you everything that is required in order to run your application in production must be stored under version control, including infrastructure as code. So including the whole description how that runs in production. So it's not enough to say, here's my bunch of Java code and here's my YAML or my Maven or my Gradle description in order to build our Java artifacts like WAR files or jar files. Because if you have a jar file, you still have to do something with it, right? You need a JVM and optionally some configuration or maybe a container. And how is that installed, right? And this knowledge is typically with ops versus DevOps stored somewhere else. And that's now the point that we store all of that in our repository. And this is what we do, quite incidentally, if we use Docker files and if we use Kubernetes because of infrastructure as code. We define everything how that looks in our project itself. The same is true for dependencies. Factor 2, for the same reason. So everything we specify on the Java side is done in a Maven POM XML, right, or in a Gradle description. So we specify the Java dependencies there and isolate them. We're not just copying source code around. Well, that's what we're doing, right? But now the same is true for our runtime. We specify all the runtime dependencies, such as which Java version do we need, how does the application server configuration look like, and so on and so forth, in our code, so that we explicitly declare and isolate that. Store config in the environments, that basically goes together with a few other things like development and prod parity, basically saying keep all the environments as similar as possible. That means that we do not want to change things between a test environment, between staging and production, and how many environments we might have. Rather than, we want to say, please run always the same thing. So basically, we build our Docker image, in our case, once, and we deploy that anywhere. And we don't want to, well, build multiple images for the multiple different versions we might have in these multiple environments. Because everything that differs between test and production is something that you cannot really test. Because if you deploy something on a test environment, then you run your tests against it, then you never know whether it will actually work in production, because it's a different thing. Even if it's just a slight difference, this is the exact difference that you then didn't test. So that's the whole point why we do that, why we say, please keep everything as similar as possible. And if we have some kind of configuration, then we store it from the outside of the application. I will show this later on how we implement that. But it's basically saying, do not change your Docker image. If you have to change things, then please from the outside. For example, from network configuration or something like environment variables. Backing services, well, similar story, treat backing services as attached resources. So, well, we want to be independent of that and be loosely coupled for our backing services. We will also see with point, 7, port binding, that we want to expose our services via port binding. That is exactly what we do in Kubernetes or even in Docker. If we specify, well, an application such as coffee shop, we actually specify a service for it, and then the application will listen to a specific port. And this is also, quite funnily, how we look it up. So let me quickly step into the code here, how that works internally. I showed you this before. Order coffee. This is the entry point of how we order some coffee, right, in our application. And what it does is, well, not much. We have our coffee shop managed bean here. We will order some coffee. And that doesn't do too much. We have another bean that is called Barista. Well, and you can probably guess that this will be some kind of HTTP client that then talks to the other system, and that is the case. What we have, I use JAX-RS on the client side to do this HTTP call. I could use anything I like. But now the interesting story is, how do I access that external system, right? Specifically now, since we run in our Kubernetes cluster. And what I do, you can see this in this URL, I do not specify an IP address, because that's not really practical, but because then I would need to change the code or need to change the configuration if I run in a different environment, and where to get the IP address in the first place, right? And I also do not specify a DNS name, such as test.coffeeshop.examplecorporation.com. Rather than, I just say Barista. Please give me the Barista application, the Barista hostname, with port 9080. And that's exactly how I want to specify that. I just specify a port where my other application will listen to, and I use the hostname to look that up. And if you remember this Kubernetes description file, this is the logical service name of the other Kubernetes service, Barista 9080. And what Kubernetes does is it does a cluster internal DNS resolution for all the Barista instances, all the running Barista applications there that I have as part of my cluster. And then I do not have to specify the IP address. I can simply say, please take the Barista hostname. And then DNS will give me one of the running instances by round robin. Then it will connect to the port 9080, which is the default port for this OpenLiberty server, and then I can just connect to it. And that's the reason why I can even hardcode that URL here, because it will not change. If I run this in a test environment, it will, in a test cluster basically, cluster internally within the same Kubernetes namespace, it will give me the IP address of one running pod for the Barista service. In a production cluster, same story. I can use the cluster internal DNS resolution to give me then the other pod here. But that's done in a dynamic way, which is a quite nice thing to do. What else do we have? Strictly separate build and run stages. Well, this is basically CI and continuous delivery. Processes execute the application as one or more stateless processes. Yes, this is what we do with the Docker approach. The Docker container knows nothing about what's running inside. It doesn't even know that this is a JVM. It just knows that this is a running Linux process. That's it. And then it just runs the process. And whatever is done internally, well, that's isolated. You literally, your whole container and Kubernetes environment only sees that there is a Linux process running, and then later on that Linux process will listen to a specific port. That's it. So for us, for our case, we run a Java Enterprise server, and that exposes port 9080, and you can HTTP connect to it. And that's a very nice model, because then you just isolate things. I could totally swap out the Barista environment to Python or something else if I like. That's abstracted by containers and by Kubernetes. For the same reason, same story with admin processes that run then. If I would like to connect into it and start, another shell script or Linux process that does some admin things, same story here. And Enterprise Java, we would implement that with application server capabilities and logs. How we do logging, well, that's a whole other story, whether we want to do a logging, but there's no time for this talk. But we typically do not log into traditional log files, because then they would reside somewhere in the container. We would have to get them out later on. Rather than we just treat it as event output, event streams, and usually log to the standard output of the running Linux process that runs as part of the container. So basically standard out of the container. And then we can use Docker logs or Kubernetes kubectl logs to get the log events, the log output later on. And then we can correlate and put that all together in our cluster. All right. A few other things. I talked about this configuration before, so that's another story what we can use. How do I do configuration? Well, in terms of the service discovery, that's already been done by Kubernetes. As you saw, I do not have to configure where the Barista backend comes from, rather than I just say, well, please do the DNS resolution. So I just made up some example where I actually put in some configuration. For example, like typical feature flag, I say, please specify whether this application is in development mode. And the typical way how to do that in Kubernetes is by a so-called config map. Config map is literally a hash map that is stored in the Kubernetes cluster with key value store, where you can store any values there. And then the interesting story is I can inject these values into the running container, typically by either environment variables or volumes, that means files, right? So I could say, please use the Unix environment variable that I call development and just, well, inject it using these values here. So then in the running container, there will be development equals to, well, whatever is configured in the config map. If I had multiple clusters, I could configure that differently, right? And now the question is, how do I get this value in my Java Enterprise application, right? Because you could, well, totally go for Java, Java system.getEnv, which gives you the system environment variables, right? And call this and get this in the code. But that's not very practical because then you just, well, it's doable, but you would have to implement that yourself. Rather than what I do, I use some extension that is there for microprofile. Microprofile is an approach, well, in order to make the whole standardization and moving forward of Java EE a little bit more flexible and a little bit faster, specifically with all organization that's going on. So what we have a bunch of, well, they are not standards, but projects that build upon a few Java EE standards, CDI, JAX-RS, JSONP, for example, and that extend, well, the Java EE platform. So for example, what we have a microprofile config project where we say, well, now we want to have injectable configuration into Java EE. Can you do this with Java EE? Yes, of course. You can write your own CDI, injector, producer method, and things like that. If you've done that, a few lines of codes, one class, but it's already been done using these projects. The same is true for fault tolerance or metrics if you want to emit monitoring data. So these are projects that can be added to Java EE. Well, you can also run microprofile standalone, actually. And that provides some, well, benefit, provides some things that you might need. So for example, if I want to add a config dependency, this is microprofile config, or fault tolerance, that is another one that I could simply add on top of my Java EE application. If your runtime, your application server supports them, you can add them in a provided way. That means you add only the API. The implementation is done by the application server. And then I can, for example, let's go to the health check resource. Let's say I want to inject some configuration here, right? Just because that's a nice example. I want to emit some more information whether my application is in development mode, right? So I could say the way how this works, I can then inject some config properties, and this annotation comes now from this microprofile project, and say, please inject the config property that is called environment, if I can spell. And that internally has a bunch of config sources where it does some lookup automatically. So this, for example, will look into the environment variables and inject that variable here. And of course, I can specify default value, default false. And it supports a few Java types, for example, you know, the primitive types, environment mode, and so on and so forth. So I can say this is now an environment mode, and then I can use, well, a JAX-RS to say response dot say OK with the content OK, and then add the header xn environment. Is it called environment? No, development mode, right? Yes, development mode, sorry. Nobody of you is paying attention. Why did you not warn me? That's correct, right? Just checking whether you're paying attention. Dev mode, something like this, right? And then we could just output this just as an example. But the interesting story is that one that we can just inject configured values here simply without coding a few lines of code here. So what I can do then is saying, well, I want to rebuild this whole thing. Oh, same is true for the fault tolerance. So fault tolerance is also a project where I can add resiliency on a Java EE level already. So for example, I can add circuit breakers or retry methods and so on and so forth. If you say, for example, the Barista capability here, a lot of things could go wrong when I do the HTTP request to my second system, right? So just as an example, I could add a circuit breaker mechanism that is now also a microprofile annotation that I could well, specify how that circuit breaker behaves. So what it basically does, well, once that method fails, at some point it will, later on, if it fails again, trip the circuit breaker and opens the circuit, and then it will not retry for a certain period of time this method and just immediately return an error to not overload your system. So there are many resiliency patterns for that, and circuit breaker is one of that's supported. Again, you could totally do this with Java EE, with interceptors, for example, but then you would have to code these lines of bunch of lines of code yourself, right? Specifying try and then increase a counter, right? And at some point you just throw the exception immediately, and so on and so forth. So anyway, let's rebuild this. And then we can rerun this in our cluster environment, right? I say build the coffee shop project again and push this again. And then, well, I should have used a different Docker tag, right? Don't reuse your Docker tags, make them unique. And then at some point we could say, well, please just reload our application. So what I do in this case, and that's also a resiliency feature, which now also can show the deployment. If I have my running pods here, oh, I hope the network is still there. Yes. That still runs the old version. But if I specify, please always pull the latest image, what I can do, I just delete that pod because I'm very mean. This is not a good idea. But now it can show one feature of Kubernetes. If for some reason that pod, that container crashes, it will immediately create a new pod for you. So it'd say, this one is terminating because I just deleted it, right? But the deployment that's still there for a coffee shop will just immediately create a new one for you and say, okay, anyway, there's a new one that is already starting up right now. And that new one should now use the new feature, and I hope I configured development mode true. Yes, and that is called development, so that should work once that's up and running. And then we can see whether that HTTP header is included here. So that's a nice way how to extend Java EE. Bless you. So if we look at these 12 factors again, then we see if we run our application in a modern way, in a modern environment, for example, in containers and container orchestration already, then we, well, quite naturally fulfill a lot of these concerns already. And if you have a further look into the 12 factors, I would say it makes sense, if we're honest to ourselves, to somewhat implement these when we're building enterprise applications, these factors. And that's, well, comes quite natural if we use Kubernetes. So that's now up and running. Health check, if we ask for health check again, then now we see, oh, that's in development mode. That's for the HTTP header. And of course, now you get the story. You could inject that anywhere in your code and use that configured value. Another technology that I quickly want to show you. So my cluster that I have here is actually an Sto cluster. It not only uses Kubernetes, it also uses this so-called service mesh technology on top of Kubernetes. What is a service mesh technology? Well, that's a technology that enhances your cluster, your microservice deployments, with a few concerns that are required for production in a somewhat transparent way without changing your application. So for example, we were talking about observability before, that you would need for modern cloud-native applications, right? And we can add observability in the service mesh environment out of the box if we let's order some more coffee, all right? We have a coffee here, and if we would order some more coffee there, more coffee, more coffee, more coffee. So now we always go to the coffee shop system and say, please, new coffee, new coffee. What we can do, we can look at, this is a monitoring technology called Grafana that ships with a service mesh cluster with Istio. Without configuring that ourselves, that already includes monitoring data, technically monitoring data, HTTP related, for Barista, for the Barista system, or for the coffee shop system. So it says, what's the request volume? We have 1 operation per second, roughly. And that is the success rate, and so on and so forth. And that comes out of the box just by these, you can look that up how that works internally, by these so-called proxy sidecar containers that, well, basically gather all the telemetry data of your traffic. The same is true for this cute little guy with the German name Jäger. That's a tracing technology. Similar story, we can look for individual requests and traces within our system, and then we can actually see what's going on in our system if we enhance this for distributed tracing. So we will see that actually the first and the second system is involved if we do this order coffee functionality, because we will see that this is a synchronous request. And of course, we can see the timing and all that, and we could have a look how this coffee shop system does the second request by posting to, well, we saw the URL before, right? But now you have a look what's going on once you want to trace individual requests. So that's a very interesting technology that enhances our, well, microservice cloud-native world with that as well. All right, that's most of it what I have for now. As a takeaway, we want to care about these 12-factor and cloud-native concerns if we're building modern enterprise applications. And there's a high chance that you're already naturally implementing a few of these. But I challenge you to have a look at these resources. And then I used containers and container orchestration to enable these concerns. I use Docker and Kubernetes and Istio, but there are certainly others as well. If you're in an enterprise Java world, what I think it's quite interesting, or what is quite helpful for enterprise projects, is if you're using Java EE or now Jakarta EE, then you can use a few of these microprofile projects to fill these gaps that were still missing in Java EE, right? For example, what we saw with the open tracing. With the tracing Jäger technology, we would need microprofile open tracing to enhance that, or microprofile config, that's what we saw, and a bunch of others where we can just fill and close these gaps. And then as an outlook in the end, the service mesh technology that I just showed you, these enable a few more concerns. For example, observability, also resiliency, and a little bit more advanced traffic routing, even more advanced than Kubernetes can do for your applications, so that these things are not a concern of your application. You do not have to implement them and ship them in each and every Java implementation. Rather than that is a concern of your environment, of your cloud-native technology that you're using. In this case, it was Istio. And I think that's a very nice way how to develop these enterprise applications, because you as Java developers, for example, or as any developers, in your application, you care about the business logic, what your application actually should do, right? So what your business value is. And all of these other concerns, for example, observability, then become a responsibility of the overall cloud-native technology, not of Java, but of, for example, containers, container orchestration, your cloud-native tech that you use. And then we can focus more on actually what we should focus on as developers, and that is then well, implementing business logic in our Java code. Right. Other than that, thank you very much for your attention. You can get all the code online. I will tweet about where you can get the GitHub project later on, once I got that published. And then you can try it out yourself. Thank you.